Last week we covered some arguments against going back to the moon, but there are compelling reasons in favor of another landing tour. Another list of which is trying to pinpoint the moon's age. We could do this by studying an enormous impact crater known as the South Pole Acre Basin. It's located in the moon's south polar region, but since it's on the far side of the moon, it can only be seen from space. Here is an image of what we call the SPA basin. This color-coded image of the SPA basin, those are the actual colors obviously. This image is from the mid-90s from the American spacecraft called Clementine. um, Unlike earlier lunar missions, the Clementine didn't orbit only around the moon's equator. Its orbit enabled it to send back data to create this topographical map of biology. Gray and white area towards the bottom is the South Pole. The purple and blues the oranges and reds around it are higher elevations. And the basin measures an amazing 2,005 kilometers in diameter, and its average depth is 12 kilometers. Now study different intervals, impulse, and create them. How they redistributed the piece of the first cross. And in this case, we especially want to know any of the mantles that were beneath the crust, not exposed to the impact. Not everyone agrees, but some experts are convinced that whatever created this basin did penetrate the moon's mantle. And we need to find out because much more than the crust, the mantle contains information about the planet's moon's total composition. And that's key to understanding planet formation. Diane? And the only way to know the phase is to study its rocks directly from values of data we'll know the rock or smaller craters. So it must be very old, about 4 billion years, given in any years. We know small were formed by impacts during the final stages of planetary formation, or if they resulted from the later meteor showers. But if we know around how about no, but such a crude estimate. We can do better than that. Besides, there are other things worth investigating, like is the water ice on the moon. Current sensing indicated that the wall of the South Pole crater was more reflective than expected. So some experts think there's probably ice there. Also, data from a later mission indicates significant concentration on hydrogen, and by inference, water, less than a meteor on both poles. We think meteors that crashed into the moon or the tails of passing comets may have introduced water molecules. Any more molecules that found their way through the floors of the craters near the moon's pole, that water would be perpetually frozen, because the floors of those craters are always in shadow. And furthermore, if the water ice was mixed in with rock and dust, it would be protected from evaporation. So I say there might be primitive life on them. That's not my point at all. Permission for astronauts, water ice could be melted and purified for drinking. It could always be broken down into its components by the oxygen and hydrogen. Hydrogen could be turned into fuel, rocket fuel. So water ice could enable the creation of a self-sustaining moon-based station. And mining can perhaps or the departure point for further space exploration. Now, the whole new tons of equipment to moon to make a fair and build life support system for moon base, it wouldn't that be too expensive. Permanent base may be a ways off, but we shouldn't have to wait for that. The dust at the bottom of the JSP basin really does have a fascinating story to tell. I want to give for a few samples.